Hello everyone, welcome back to my YouTube channel Summarize TI. As part of today's video, we are going to understand conditional logic we have in LangGraph. Suppose we ask a question to our LLM. At the same time, we save this question in the shared state, which is here. Storing this question in the shared state allows every subsequent step in the graph to access and use it, which is external search step and generate answer step. And if we have some more steps, those steps also can access the shared state. The LLM here will pause and think about the question. Now, decision, or you can also call it as conditional logic, will come in picture to decide whether to call external search step to gather additional information and return final response to end user, or directly call generate answer step to return final response to end user. In short, conditional logic allows you to control the flow of your graph based on the current state or data. Think of it like a decision point in your workflow. Depending on certain conditions, your graph can take different paths. So here we have only two paths, but we may have multiple paths, and decision logic supposed to decide on which path it has to go based on some conditions. Condition logic is similar to this if else statement, but gets applied at the graph level. This is crucial for creating dynamic and context aware AI agents. Now, let's see the actual implementation of conditional logic. Let's go to our Visual Studio. Let's create a file which is condition.py. Before starting the development, we require one of the third-party library to be available in our local, which is LangGraph. So we can say pip install LangGraph, and this particular command either we can hit in the command prompt or in the IDE terminal. So let's copy paste and hit enter. It will allow you to install. So I'm getting this particular message requirement already satisfied because I'm already having this particular library in my local. So now we can go ahead and start our development. So first I'm going to import type dictionary from typing. From typing, import typed dictionary. Now from langgraph dot graph, import state graph and state. So I will be explaining all these imports later in the same video. Let's go ahead and proceed further. So the very first thing is we require the shared state. So on shared state, I've already created a detailed video. You can go ahead and check out that video. Let's go ahead and create a state. We can say class state and provide type dictionary. And this state, as we discussed earlier, we require three things. The very first thing is the question, which is given by the end user, and the answer, what we are going to provide to the end user. Now, the third thing is need search. That particular variable will decide either we are going for the external search or generate answer. Great. So let's create these three fields. So the very first one is question, which is of type string. And the second one is the answer, which is also type of string. The third one is need underscore search, which is also going to be a type of string. Now we have our shared state class with us. Let's create the search tool, which allow us to make a call to the external system and get the required details. So here I'm going to say define search underscore tool, take query as a parameter. So query, which is of type string, and return the string. Great. So here I'm just going to return the dummy string, but what you can do, you can write the actual code which will make a call to the third party system and get the data. And I will be creating a very detailed video which will have all the integrations, RAG and everything. But for the education purpose, I'm just hard coding this particular string here as part of our written statement. So I'm just mocking that particular response from third party. So I'm hard coding the string and returning the same. Search result for provide the query. Great. So this is done. Now this particular search tool will get called by one of the step, which is external search node step. Okay. So here we are going to pass the state. Great. Now from state, we are going to get the question and pass it to the search tool. Search underscore tool. And here you just pass the question. And this is what it is expecting here. Okay, great. Now we are going to return this particular string. So we require a variable to store this particular string. So we are going to say result. Okay. Now here, just give enter and provide the return statement. So in the return statement, we are going to provide two things. The very first thing is the question, which is nothing but state, and then question. And the second thing is answer. So answer is going to be the format. Then here you can say result, which is this variable, and hyphen from search. So whenever this particular node will get called and it will return this hyphen external search, which means we called this particular function and got the result from external search node. Now, similar to this, we are going to create one more node or step, which is the generate answer. So we can say here define generate underscore answer, generate underscore answer, and this will also require the state. Great, the shared state. Now here I'm just going to return the question as is, like whatever we are having here. And apart from this question, I'm going to say the answer. And answer is like hard coded, which is the response is from generate answer. Okay, so let me go back to my graph and explain you things again, where we are and what we are doing. We have created this particular node here, external search, and external search is calling the search tool. Okay, and the second node what we have created just now is generate answer. So we have these two nodes available with us. Now we have to create a graph and this decision node or the decision logic, which will decide either to go on the external search or go on the generate answer. So let's go back and define the node logic. So we can say define check underscore node, and this is also going to take the state. Okay. Now here we are going to create a variable, the local variable, which is need underscore search, and provide the default value to no. Let's try the if condition, which will say if need search is available in question. Okay, question dot lower. Okay, so make the lowercase. And if in our question we have a keyword need search, then this condition will get call. And here we will simply say need search equal to yes. Now we will return the result. So here we can say return question. Okay, and question will be coming from the state. The second thing is going to be the answer. So answer we don't have. This is just a conditional logic. Okay, So this will be empty. Now after this, we are going to have the need search, and let's provide the need search variable here. Now we have the check node with us, and let me repeat again. So here in the question, we are checking if we have need search string available. Yes, then this particular variable will get changed to yes, and same thing will get saved in the shared state. And by default, it is going to be no. Good. Now let's go ahead and define our root. Okay. And in the root, what we are going to say? We are going to say define root state colon state. I will tell you what the root is. So state colon state. So let's try the if condition. If we have yes in need search. Okay. If need search is yes, then what you gonna do? You gonna return external search node. Okay. Or else you are going to return generate answer. Okay. So which means we have written a root which says if in our need underscore search we have yes, if this property having yes as a value, then you have to call this external search node, which is this one. Okay. And if you have no, then you call generate answer. Great. Now how it will get called? Let's see. So now we have all the nodes ready. So we have this decision logic with us. We have external search. We have generate answer. Now we have to define the flow. So which will get called first and what is the sequence of all these nodes. Now this is the time to create a graph. So we can say graph equal to state graph. And in the state graph, you are going to pass the state, what you have created here. So this is the state we have passed here. Okay. And this particular state graph will allow us to create an actual graph, which is going to have all the nodes and the edges. Okay. And the sequence also, like which node will get called when. Now let's go ahead and create a node. So here we can say graph dot add node, and here you can say check underscore node. Why? Because we are going to have three nodes. The very first one is this, second is this, and third one is this. So we have to define all the three nodes. So the very first one is this, and the second one is going to be the external search node. Now, after external search node, we have the generate answer. So we require that also. So this is generate answer here. Let's copy paste generate answer here. We got all the nodes here. Now, after getting all these nodes, we have to set the entry node. So from where the code will take the entry. So we can say graph dot set entry point, and it is going to be the check node. Okay. So code is going to start from the check node, and from check node, it will be going to either external search node or the generate answer. So we have to write that particular code. So let's go ahead and write that. So here we can say graph dot add conditional edges. Okay. Now the very first node we know it is going to be the check underscore node. Now after check node, you have to write your root here. Okay. So let me go back and check the spelling. Oh, sorry, it should be E. Okay. The spelling is wrong. So as we know, root is going to return two things, either external search node or generate answer. Suppose the root returned external search node. In this case, it will call the external search node, which means it will call this particular function, external search node function. Now, if it returned the generate answer, then in this case, it is going to call the generate answer node, and generate answer node is nothing but generate answer function. So this is how the calling will work. Now, once we have this graph ready with us with the nodes, edges, and conditional logic, we can go ahead and compile this graph. So you can say app equals to graph dot compile. Okay. And once the graph is compiled and ready to get used, you can invoke this graph. You can say app dot invoke. Now, after invoking this app, we do understand we have to pass the question, and everything gets started with the question, and our check note function and everyone is looking for the question. So let's provide this question here. You can say question, what is LangGraph? Okay, it will return a result. So we can say result equal to this, and this is the right time to print our output. Here we can say print result, and we do understand from the result we are expecting the answer. Okay, so let's keep this answer here. Good. Now let's go ahead and execute this code, and then I will be explaining how the flow is working. So let's go ahead and execute. Now you see, we asked what is LangGraph. So it says the response is from generate answer. Okay. Why? Because when we tried to invoke this particular graph, okay, it went to the check condition node. Okay. In the check underscore node, because the flow is starting from check underscore node. So as soon as it went into the check underscore node, it saw in our question, we don't have this need search string, which means our need search property is going to be no. Okay. If the property is no, and once it will go to the conditional logic here, okay, which is our root. So it will go to the root, and in the root, it will see if it is no, then it will return the generate answer. So at the end of the day, this generate answer function will get call. So suppose if I say what is LangGraph, and anywhere if I provide need search as a string, anywhere like in between, but it should be having a need search. So now if I execute my piece of code, you see my output got changed. I'm getting this from external search. How? Because when we tried to make a search here, okay, as soon as we invoked our graph, it quickly went to this particular check node function. In the check node function, conditional logic, it saw in my question, I have this need search string, which is I have given here. Okay. Now, as soon as it sees this particular string, it says need search. Yes, correct. I need that. Now it will go to the root. Now in the root, it will see this particular condition getting passed. Now it will call this particular external search node. And the external search node, we have this particular function. So this function will get call. And inside this function, we are calling this search tool. So from search tool, we got search result for our query, and then we got the response in the result, and then we append this external search. So this is how our external search node function got called. Now, because if you see, this is our flow. Okay, so we are calling the very first is the check node, and whatever check node is returning, our root is taking care of that particular call. And this is how the conditional logic works in LangGraph. Thanks for watching this video. Please don't forget to like and hit subscribe button.